Everybody, we'll get started for today. Welcome to our second video for CIS 245. Today we're going to be talking about Chapter 1 and the basics of web hacking book. So if you haven't taken a few minutes there to go back and watch our first introductory video, please do that, because in that I lay out what we're going to cover for the course, the material, the books, the syllabus, everything. So you should have a pretty good idea overall of where we're going to go for the entire semester. Keep in mind this is a summer course, so it is only 12 weeks, so we're going to be a little bit shorter than your average or your normal fall or spring semester course, which is our typically 16 weeks. Take a look at the academic calendar, dsu.edu, and just note any particular dates of interest to you. There'll be some holiday stuff, although that probably won't affect us too much as far as the course goes. But dates to withdrawal and things like that are usually ones that you need to pay attention to. I'll do my best to notify you through the system, through Starfish and some other tools that we use here at the university, but ultimately it's up to you to do that. So please keep track of that, and let me know if you run into any issues with anything. As far as missing assignments or labs, we talked about that in the introductory video as well. So please be proactive and communicate with me. I realize it's the summer and a lot of people have things going on, and so just let me know, and I can certainly work with you to make adjustments there. This will be our folder, and so everything, all the content that I'm going to deliver through the course will be coming through here. Tentative schedule, check that out, and you can see more or less where we're headed and what I'm going to expect week to week as we go. And I should have this filled out pretty quickly for the entire summer semester. So you'll be able to kind of read ahead, work ahead there if you want to. There's a syllabus, download a copy for yourself if you'd like that. Slides, labs, and some resource material here. So as we get to the end of our discussion today, I'm going to come back and we're going to take a look at these ISOs and VMs, because one of the goals for our first lab, we'll also take a look at our first lab, one of our goals for that is to get your lab environment set up so that as we start talking about these concepts and these tools, you have a safe environment to run those in. And so I'm going to walk you through how to do that, and that's going to be the purpose of our first lab. And I do that for a variety of reasons. And one thing that hopefully you'll see, not only in the course here, but then as you progress through whatever program you're in here at DSU, that really what I want to get out of these, our 12 weeks together, is setting up a solid foundation for topics, techniques, technology, things that you're going to see later on in other programs. And so I have a very specific reason why I'm going to do everything that we're going to do, everything that we're going to cover, the labs that we're going to do, and how we're going to do those, because I think they'll be of great benefit to you to have been introduced or exposed to them early on here, as this is an introductory course and usually one of your foundational courses. It's a 200 level course. It's typically something you take early on in your career, your program here. And so I think it's going to be valuable. That's why, that's why I do that. So with that, then, I've got a few slides I want to go through, and then I'll try to do a fair amount of hands-on demonstration type stuff so that you can see, as we work through the material, how that relates into, in particular, web applications, because that's what we're going to be talking about today, is trying to understand, at least at a high level, how applications work. The whole purpose or focus of our first book is to hack web applications, and it's not necessarily hacking. Hacking kind of has that alluring term to it, and oftentimes it's a misunderstood term. The idea is to find security weaknesses within the application that allows someone to be able to use that application in a way that it wasn't intended, and oftentimes that can be to disastrous results for the person that owns that site, through data breaches or compromises of further systems within their network. And so, our purpose is we're going to look at this very offensively. Pretty much everything we're doing in this book, in this first half of our semester together, is going to be offensive in nature. We're going after a website, we're trying to attack it, we're trying to find those weaknesses, and because we're going to be security professionals, then we're going to ethically report those weaknesses so they can get patched. If we're working for an organization and part of our job is to test those for organization, we're going to report that to the organization. If you become a penetration tester and part of your job is to evaluate web applications, then you'll be able to report those as part of your penetration test result. If you're going to become a web application developer, then part of your job will be to ensure that you understand how people can exploit your application so that you can write your code in a way to protect that. And so hopefully over our next few discussions together, you get a pretty solid understanding of how they work. So we'll start off talking about what is a web application, because the term web application in and of itself can be a little ambiguous or a little confusing, and it's oftentimes used in a variety of different contexts. For the most part, everything that we interact with via the browser is a web application. Right now you can see that I'm delivering these slides through Google Docs. So I have a more or less a full-up PowerPoint type slide creating tool inside of my browser. This is very much an application because this, even though it's being rendered in my browser, it's using a variety of these client-side technologies that we're going to talk about, namely HTML, CSS, and JavaScript. Even though it's primarily using those, it performs a lot like a standalone application, like PowerPoint would. Of course, it doesn't have the same exact features, but it's pretty powerful. This is beyond what we had for websites, 10 or 15 years ago. And so web application oftentimes is, we're looking at something that we're doing in the browser, whether that's on a desktop or a laptop like we're looking at here, or on a mobile device or a tablet. It's browser-based, and it performs very robust, rich functionality. You can still have a lot of websites or web applications that are very simple. We've all been to sites that don't do anything more than maybe provide us with some information. They're very static. They're oftentimes called a brochure site, and that is that I just take my business brochure and I turn it into a website. And there's no interactivity with it. There's nothing that makes it dynamic. I can't create an account. I can't log in. I can't search. I can't submit a form. I can't do anything. You can't do anything with it. So it's very static in nature. And those are typically referred to, at least in my world, my worldview, a website. But for the most part, website, web application, it's very hard to determine the difference between the two, and for the most part, I think we can just settle on that we're talking about something that we're accessing, a resource that we're accessing through our browser. How these things are built are important. They're a little less important when it comes to the purposes of our class, because we're going to have a particular environment or a web application that we're going to attack, and we'll talk about that here at the end of our discussion today. But it is very important in general to understand how applications are built, but beyond the scope of what we're going to talk about. In general, you can have custom code. So you're hiring somebody, or you yourself are sitting down and you're creating a website completely from scratch. You start with a blank text editor, a blank Visual Studio, a blank whatever, and you write all the code yourself. Right? So that's one approach, very time-consuming approach. You may have a hybrid approach, and that is that you have these frameworks. I'll talk about frameworks and content management systems here in a minute. You use a framework or content management system, so something that's either closed source, proprietary, or open source. You get the source code, and then you make your own custom modifications to it. So maybe it's a framework or a content management system that has a login system, and then you create some custom functionality to extend the functionality of the site. Right? So kind of a hybrid approach. We have mobile devices, and I think it's surprising for most people when they realize that a lot of mobile applications, while they may seem native, that is, you install them from an app store, all they are is a browser on that mobile device that doesn't have any Chrome. The Chrome is all the stuff around the window. So if I made this thing full screen, on a mobile device anyway, it'd be hard to tell that that wasn't just a browser, that was a native application. And so you also have mobile native, though, in which case then you may still be dealing with a mobile application that has a browser. It's using a browser within the application, but there's other graphical components to it that are native to that Android device. I won't get too deep into mobile development here, and so maybe sometime down the road we'll have a course you can take to get a little bit deeper into that. Frameworks, content management systems, right? So you've probably heard of WordPress, or maybe a little more obscure Drupal, Zen framework. These are content management systems, content management frameworks that as a developer, I would choose one of these because I get a ton of functionality when I download the WordPress website, and I don't have to write any of it myself. And so it saves me a lot of time. I can deliver functionality that I don't have to write. I don't have to charge somebody for. They don't have to pay me to develop it. I can just do those customizations that they're looking for. I can create a theme. I can create, I can create a plugin. Plugins are the things that you put into a WordPress site to make them more functional. And so you have all these approaches, and if you go down the path and you do more web application security auditing, penetration testing, or even development, you're going to be working in these areas. You're going to be working with all of these different things, and it's important to understand if let's say that you're doing an audit and your site is a WordPress site. It's important to understand that because there may be a whole slew of known vulnerabilities that will allow you to be more effective in your penetration test against that WordPress site. Penetration test, because I've used the term a couple times now and I haven't defined it, so just in case you're not familiar, penetration test is the kind of industry term of saying security audit, and so there's organizations that offer those as a service. and so they're hired and contracted to come in, and they can test the security of a website. They can oftentimes they'll test the security of the networks. They'll try to get physical access. They'll try to do social engineering, and their ultimate goal is to as real world as they can, test the security, all aspects of the security of an organization, and then report the findings. Say, yep, we were able to penetrate your firewall because you had an old service running, and we gained access to your systems, which ultimately led us to your database, and we could have anyway, dumped all your database information. So that's more or less what a penetration test is, and we'll cover it more when we go into the second book for the course, which talks more about the network side, and oftentimes penetration testers are a little more focused on the network side. Okay, so that is what a web application is, and some of the underlying ways in which web applications are built and delivered, and how consumers use them. We have some core components here that we need to talk about, and suffice it to say that web applications are relatively complex. They have to run on a machine. They're no more, a web server is no more than software that serves up your websites. Your websites then are components within that web server. And then there's all the stuff that happens in between. There's the browsers that we have to use to access them. There's the requests that we make, and we'll talk through some of that today. And so the point of that is that we're not going to cover everything. You'll start to get that as you get deeper into the courses here. But this is just to give you a good idea of, in general, how they work. So it may almost be an oversimplification, but I just want to make sure that everybody understands the basics of how these work. So we start with web servers, and as I mentioned, a web server is just simply software that runs on a machine. And so we can pick any machine that we want. Typically you're going to find these web servers are going to be installed on a Windows Server machine, so Windows Server 2008, 2012, 2000, whatever the current version is, or a Linux machine, in which case there are a lot of Linux distributions that you can install a web server on. That software then, you install it like you do pretty much any other software package. What it does then is it starts itself up, it runs in the background, and it listens on a specific port. All right, so machines are designed to be accessible via their IP address, as well as the different ports on the machine. And so this port then, for web servers, is typically port 80. And we'll talk more about ports when we talk about port scanning and the importance of being able to identify particular popular ports. Port 80 is very popular because almost all web servers on the planet listen on port 80 or port 443, because that is what their default is, and that is what our browsers by default communicate on, are those ports, right? So if our address is like the house, the port's kind of like the door, and on port 80 that tells us what port we're talking to on that machine. This creates a client-server relationship, in which case our client is the browser and the server is, of course, the server. And so now we've just established a relationship with the client, our browser, and the server, and we have two-way communication, right? I want to request a website. I want to go to dsu.edu. And so in my browser, I open up a tab, or open up a window, I type that in, and I know to communicate with dsu.edu. I make a contact or connection to that server. We talk. There's some networking stuff that happens there. TCP and three-way handshake and things you'll get more in depth with your networking classes, and then we start a two-way conversation. Right? I request the page, the server returns the page for me, and then my browser marks it up, makes it look good. I click a button, I request a new page, sends back to the server processes that request and sends a response back to my browser, back to my client. And then we just do this the whole time that we're interacting with that particular server until we close our browser, or we move on to a different server. All right, we'll take a look at a web server. So we're gonna have two virtual machines we'll talk about here, Kali and Backtrack. And so we'll look at the web server on those machines because that's the one that we're primarily concerned in. There are a lot of popular web servers. So Apache is going to be the one that we'll use for the most part throughout the course. Nginx is another very popular one. It's open source, and you'll find that on a lot of Linux distributions, as well as IIS, which is Microsoft's Internet Information Services. So websites that are developed using Microsoft products will oftentimes run on a Microsoft server and a Microsoft web server. So plenty of servers out there, but these three here are going to be the dominant ones. And so we'll look at header information here, and you have ways in which you can fingerprint the type of server that you're interacting with, right? So you send your request to that server, and it's going to send back some information, and that information oftentimes will tell you the type of server that it is. And that's another piece of information that's very important, because that can tell you if you know that there's a vulnerability in Apache, then if you know you're interacting with an Apache server, you might be able to take advantage of that from an exploitation perspective. All right, so we have web servers. We talked a little bit about the browser being our client here. A core part of the communication that takes place then between this client and the server, between the browser and the web server serving up that page for us, the web application, is HTTP, which is the Hypertext Transfer Protocol. This is a protocol that when I establish a connection, right, when we first establish communication from our browser to that web server, HTTP then is the underlying language that we use to communicate with that. So we establish our connection, and then I use HTTP to request resources. These resources are our web pages, right? So once we've established a connection with the server, then we use HTTP to request the pages. One of the primary problems with HTTP is that it's stateless. Stateless means that it is not able between requests, right? Every time I want to go to a new page in my browser, I have to initiate a new HTTP request. That request goes to the server sends the response, right? And so that's how we navigate through an application, is through a series of HTTP requests and responses. But it's stateless, and so how HTTP has solved that situation, and I guess first of all, what does state mean? Well, if we go to a website, it needs to maintain state about our session with it. If we go to Amazon and we add something to our cart, in between those requests, as I go from different pages, as I go through the checkout process, as I shop around Amazon.com, if we didn't have a way to maintain state, then there's no way it could keep track of who I was, what I've added to my cart. We'd have no ability to do e-commerce or anything else on the web. The original web, all those years ago when it was initially conceived and implemented, it wasn't designed to do what it does today. And so as you study more about the web, you'll see that a lot of band-aids have been applied in order to make it do what it does today. And there's some exciting things going on with changes, even to HTTP, because the HTTP protocol has been around since the mid to late 90s. And so we're well overdue for an update in that protocol, and one's coming. Right, so we need to have state, and we'll talk about HTTP headers and how we have implemented in a way using cookies in the browser to maintain state, and why you as a security person would be interested in how that state is maintained and what you can do with that. So we're going to talk about that here in a minute. It's also, there's no security built into it. Inherently, there is no security. And so when you go to a site, oftentimes, and there's been a massive push for this lately due to, if you're following the news, you'll probably know what I'm talking about there, and to establish security, right? So without any way, HTTPS is what I'm talking about, SSL or TLS. Without the ability to do that, our requests, our HTTP requests and response between the client and the server is not protected. It's unencrypted. And there are a lot of intermediaries between me, my computer, my browser, and what I want to connect to. If I make a request to dsu.edu right now, between me and that server, there are several machines that my traffic hops through. Along the way, anybody can sniff that traffic out. And so let's say I went to dsu.edu and I wanted to purchase something. I don't think we sell anything on the site, but let's just say I did. If I want to submit my credit card, I sure don't want anybody to be able to intercept that and steal my credit card information. And so we've implemented something called HTTPS. HTTPS, you can see here in my URL bar, that is what I'm talking about. Right? So when you go to a website, if you type in HTTPS, that means that it's secure. You're using a secure connection between your browser client and the web server. And that anybody in between they can intercept the communication potentially. It's not trivial, but they can do it. But they can't decrypt it. They can't understand what it is because it's encrypted, it's secure, right? And so that's the point of the difference between HTTP and HTTPS. One of the first things you're going to want to do on a site, if you're ever doing some sort of an audit, is determine if it's handling sensitive information, and then if it is it using HTTPS? If you go to a login page, and that login page is not secure, that means when you submit your credentials, your username and your password are not protected. So there's the potential that someone could see those, and that's bad. All right, so we'll take a look at our browser and then the DVWA. And I'll just say the acronym once, and then I probably will, or I'll just spell it out once, and then I won't mention the full. We'll just use the acronym from here out. It's the damn vulnerable web application. And that's what our first lab is going to be about. We're going to be setting up our test environment, so a virtual machine to use, and then we're going to be installing the damn vulnerable web application in order to have an application to attack. It's intentionally vulnerable to allow us to attack and exercise our skills on it. Okay, a little bit more about HTTP. We have a couple of, again, there's more to it, but these are some of the more important things, is that when we do an HTTP request, we have headers that are sent both for the request and for the response. And what these headers do, for a request, so when our browser sends them, they instruct the server what we're looking for. What is the resource? And we can also send things like cookies. When the server receives that request, then it sends a response. So it can send not only the document, the HTML page, but it can also send instructions to the browser like set a cookie. The set cookie one is particularly important because we're going to see here in a second that we use that header in order to set a cookie, which then becomes our session identifier. Our session identifier is the way that we've implemented to have state in our applications, between our browser and the servers. Okay, so we'll look at that in a second. Status codes are another way that servers can communicate to a browser and tell them that a certain event has happened. So 404 means that whatever you requested was not found, and that just indicates to the browser that I got your request, but I couldn't find the document you were looking for. And so you've probably seen on a variety of sites either a plain Jane vanilla, just 404 not found, or some sites have a much nicer looking page, and that is that they're telling you the same information, but it just looks a little bit better. An example of that, if I can find one, github.com, and I'll just type in some garbage here. Hopefully that's not, yeah, see, so here's a 404, right? It just looks a little bit cleaner because GitHub has taken taken a little bit more effort to make it look nice, and then also give you the ability to maybe better search out what you're looking for. But the response here was 404, and we'll look at those codes here when we look at HTTP headers. Common ones, the book lays out, they're kind of grouped by number, 400s, 500s, 300s, 200s. In particular, you'll commonly encounter 404. 503 is a server error. So that means if you did something, let's say that you're interacting with the application and you sent some sort of input to the application and you generated a server error, that's interesting from a security perspective, because that means that whatever you sent may have affected the programming of that website. Websites, web applications, all they are is code. 301 redirects, oftentimes you get those sent back to you and they're automatic. And unless you have a way, you'll see here I have a bunch of tools that I run in my browser in order to kind of detect those things and inform me of those. But if you're not doing it, so for the average user, it happens like transparently. There's a redirect, and the browser just gets instructed to go somewhere else. So you send your request to the server responds, and it says, nope, it's not here, you need to go here. Your browser just follows that redirect, and it happens pretty much automatically, and so fast you don't even really notice it. 200 series, 200 status OK. Those are oftentimes the response code that you get, just saying that the server received your request, and here is the response. So it received it, processed it fine, and here's the response that you're looking for. Okay, so what does this all mean? Well, let's take a look at, we'll go to D2L, and one of the things you have available in pretty much every major browser now, and I know for sure Firefox, Chrome, and Internet Explorer have this, is a set of developer tools. And so with Firefox, I am using Firefox, you can right-click anywhere on your page, and you can inspect element, and this will open up the tools, right? So this tool, these developer tools, they're going to look different depending on what browser you're using. They are very important because they provide us a wealth of information about the website that we're currently looking at. We can inspect the HTML. The HTML is the code that provides the structure. It's like the user interface instructions. How does this supposed to look? You have a console, which we'll talk a little bit more later when we start looking at trying to do some exploitation. Debugger, that's a little bit more of a programmer thing. Style editor, that's more of your designer. So this is telling you about the styles that make this site look the way it does. So styles are cascading style sheets, CSS, and HTML. Those are the two components you have, primary components you have for your layout. Performance, oftentimes you're not as interested in that from the security side. This is just telling us how well our page performs. But then the network, and the network is important.